Let's learn about myosin and actin interactions. Myosin-actin interactions is also called a sliding filament theory. Now what I've drawn here is an actin, and in blue here is the myosin. Okay. And if you just recall real quickly, here was our sarcomere, and you have actin, and in between you had the myosin, and here is that actin again. And what's happening is this myosin head or myosin is interacting with that actin, and that's what we're seeing. This is what we're seeing here, okay, but a closer view. Okay, so the actin will have a binding site. The actin will have a binding site for the myosin component called a myosin head. Okay, this is an H. Okay, and this then is the myosin head. Now, the myosin head will have attached to it an ATP molecule and an enzyme called ATP, and an enzyme not called ATP synthase, an enzyme called ATPase. Okay, ATPase is an enzyme that hydrolyzes ATP, which means it takes a phosphate group off of ATP. Okay, so now the way I've drawn it here, you can see clearly that the myosin head can't bind in this spot. This is the spot where the myosin head needs to bind. The way I've drawn it, the myosin head is not in position, obviously, to bind in that region on the actin. So what has to happen? Clearly, the myosin head needs to move so that it can then be in the position to bind in its binding site. So what happens is the ATPase enzyme gets activated, and when the ATP enzyme gets activated, the ATP gets hydrolyzed, and we know what happens when ATP is hydrolyzed. A phosphate group comes off, and then of course, so it hydrolyzes the ATP, and then you have free energy that's released. Okay, so in order for this myosin head to interact in its or bind in its binding site on the actin, that myosin head needs to be moved. And so what's going to happen is the ATP is going to get hydrolyzed by the ATPase. You have free energy that's released. That free energy is used to move that myosin head. It's used to move that myosin head in position such that now it can form cross links. They're called cross links. These are small covalent bonds that are going to form. So these are cross links, or linkages, or cross links that are formed between the myosin head and the binding site on the actin. And once the ATP is hydrolyzed, what's left behind is, of course, an ADP molecule and an inorganic phosphate that still remains attached to that myosin head. So now the myosin has formed these cross links, and it is now bonded. It's attached to its binding site on actin. Okay, so once these cross links have formed, or these cross bridges have formed, the next thing that happens is this ADP and the phosphate, the inorganic phosphate, leaves. And when that happens, when the ADP, so now you have the loss of ADP and the loss of the inorganic phosphate, and what happens then is this myosin head is going to move forward. It moves forward. Those cross bridges get stronger, and so you still have these cross bridges, and what happens is this myosin head changes shape. It changes shape and it moves forward. As it moves forward, it takes this actin along with it. As it moves forward, it takes that actin along with it, and then to release that actin, what has to happen is an ATP has to come along and bind to that myosin head again, And when that happens, there's a change in the shape of that myosin head, such that now it no longer holds these cross bridges. It no longer can hold on to those cross bridges. The cross bridges break, and then you go back to this original position where the myosin head is out of the position from the binding site of actin. So the overall cycle, what happens is, one, you have ATP hydrolyzing, and you have then, of course, your energy that's released, your free energy. When that happens, the myosin head is then moved into position. So now we're at this step here. The second step, what happens is you have the formation of those crosslinks between the binding site on the actin for the myosin head and then the myosin head, and you have the formation of those crosslinks because now the myosin head is in position. Why did that myosin head come into position? The myosin head came into position because of the loss of the phosphate off of that ATP. That energy was used to move that phosphate head back. And so, to move that myosin head back. Once that myosin head is now in the space to form crosslinks on its binding site on the actin, these crosslinks are going to form. Next, what happens is you have the loss of that ADP and the inorganic phosphate. When that happens, there's a change in the shape of that myosin head such that it moves forward. It moves towards the M line. Okay? It moves towards the M line. But what happens is, because you still have those crosslinks, it takes that actin along with it. And so now actin has moved towards that M line, right? That middle line in that sarcomere. And so that is then step 3. This step 3, where the myosin head moves forward, is called the power stroke. Okay? So if we look at the sarcomere, here is actin. Here is the myosin. Okay? And this is relaxed muscle, where the muscle is not, where the myosin and the actin are not interacting, and then you then have the contraction. So this is where the muscle is contracted. Okay? And so you see what happened. The actin, you see the actin here, the actin moved towards that M line. And how did it move towards that M line? Because of that power stroke. That power stroke because of the loss of the ADP in the inorganic phosphate, and because the myosin head is still attached to the binding site via these crosslinks. And once that power stroke happens and the actin is moved, well, the myosin head needs to detach. It needs to detach again. And so how does that happen? Well, an ATP molecule comes along, binds to that myosin head, that changes the shape of that myosin head and puts it back into position 1, where now it is no longer able to maintain those crosslinks because the change in the shape of that myosin head. So the crosslinks break and the myosin becomes unattached to that actin. And so this is how these interactions occur. This is how this muscle fibers go from relaxed state to contracted phase. They go from relaxed state, where the actin and the myosin are not interacting, to where the actin and the myosin have interacted, and you have the power stroke, right? The power stroke, and that has moved that actin towards that M line. Now these interactions between the myosin and actin, there are many interactions that occur. So this is not all happening at once. All these interactions between myosin and actin, between each myosin head and the actin, is occurring many different times. It's happening over and over again. Okay? It happens over and over again to finally then have contraction. Okay? So next we're going to talk about how actually this actin and myosin are going to continue to remain contracted, what's going to then release that contraction, And we'll talk about the regulatory components of this interaction between myosin and actin. Okay, hope this helps.